Hi, welcome to IRE YouTube channel. It's me, Dr. P. Sridhar, working as a professor in Institute of Aeronautical Engineering. Today, I am going to discuss about Ohm's Law. This is the fundamental law highly required for understanding of various current and voltage relationships of various passive elements in the electrical circuits. We have discussed about voltage, current, and the relation between voltage and current. What is the difference between voltage and current also we have studied with different animated videos. And in continuation to that, now how that voltage and currents are exactly related, and with the help of some mathematical relations also, this video certainly enlightens us for better understanding of what is the relation between the voltage and current. Relationship voltage and current and resistance is correlated with the help of Ohm's law. Ohm's law has been stated by a great scientist, Ohms. On his name only, that Ohm's law came into picture. Now, as per this Ohm's law, the statement of this Ohm's law is, at constant temperature in an electric circuit, the current I flowing through a conductor is directly proportional to potential difference applied. So, how much of voltage it will be applied across any element, and once the potential difference applied or some voltage is applied across any element, because of this potential difference, the potential difference is nothing but difference in charge concentration on either terminals of that particular conductor. Now, once the charge concentration is different, then automatically because of this difference in the charge concentration, there will be a flow of current. Now, once the potential difference is applied across two terminals or across any element, this potential difference drives some amount of current through it. So it means once the voltage is applied, current will appear and the current will pass through any electrical element or any element. If there is no voltage is applied to that particular component, then it is very clear that there is no charge passing through that particular element. So voltage is applied, current will appear. The relation between the voltage and current is stated with the help of Ohm's law. Here, the temperature is very important here. Now, let us maintain a constant temperature. Now, at the constant temperature only, this Ohm's law is stated that voltage is directly proportional to current or current is directly proportional to voltage. Now, if you are eliminating this proportionality constant, then a constant R will comes into picture. That is nothing but V is equal to I into R. This R is nothing but, what is this R? R is nothing but it is a property of that particular element across which that voltage is applied. The R is nothing but it is a proportionality constant. That is a property. It will be offered by that element which is called as a resistance. The resistance is nothing but it is the physical property of that element across which the voltage is applied. So straight away we can say that V is nothing but it is the applied voltage, and I is nothing but it is a current passing through that element. R is nothing but it is a resistance of that particular element. Now this V is equal to I into R is nothing but it is called as a Ohm's law. So Ohm's law's mathematical relation is V is equal to I into R. So what are the limitations of this Ohm's law? Limitations are, it is applicable only for metallic conductors such as copper, silver, etc. It is not applicable for semiconductor devices like diodes, transistors, amplifiers, etc. Ohm's law is exactly fitted into this pie chart, and this pie chart is highly helpful for us to determine or to establish the relation among voltage applied, current passing through, resistance of that element, and the power consumed or power developed or power loss across that element. So this pie chart has been divided into 4 quadrants. First quadrant is talking about voltage. Now how much of voltage it will be applied, and in the first quadrant the voltage is developed with the help of the remaining elements, remaining quantities, electrical quantities. What are the remaining electrical quantities? Power, resistance, or power, resistance, current. So with the help of these quantities, how that voltage is defined. Now you can see, now in this first quadrant, now the voltage is defined. Now it may be voltage is equal to square root of P into R, or voltage is equal to P by I, and voltage V is equal to I into R. So this is from the first quadrant. It is very clear that the voltage applied or the potential difference across that element can be written as square root of power developed across it and the resistance of that element. Now that is the first thing. And second one is the voltage can also be written as the ratio between the power developed to the current passing through it, or the voltage is also equal to current passing through it and the resistance across the element. So this information is straight away it will be available in the first quadrant. Coming to the second quadrant, amps. So this, in the second quadrant, we have developed the formulas, the mathematical relations to know the electrical quantity current in terms of the remaining quantities like real power, voltage and the resistance. Now this current can be written as I is equal to square root of P by R, or I can also be written as P by V, I can also be written as V by R. Any one of these three is useful to determine the current I, which is the electrical charge passing through that particular element. Now coming to the third quadrant, in the same manner, third quadrant gives us the relation or to know the power developed or power consumed by the particular element can be computed with various electrical quantities such as voltage, current and the resistance. So coming to the fourth quadrant, the fourth quadrant is the resistance. Now, if it is required to calculate, if we want to know whatever the opposition property of that particular element for external changes, now that is nothing but the resistance R. This can be computed with the help of or in terms of the remaining electrical quantities like power, current and voltage. Now this fourth quadrant will give the relation in terms of the real power, current and the voltage. Now if you could observe this complete pie chart, then this pie chart is completely gives the relation among four different parameters. One is real power, you can compute the real power, voltage, current and the resistance. And in addition to this, now one more triangle, if it is possible, try to remember this triangle also. This is let voltage and this is I and R. So suppose if we want to calculate the current I is nothing but you can represent V by R. Now just if you want to determine this current I is nothing but the ratio between V by R. Or suppose if we want to calculate R. Now if you want to determine this, then the ratio between V by I. Suppose if we want to calculate this voltage V, this voltage V is nothing but that is a product of I into R. So this is also called as a Ohms triangle. This Ohms triangle, this pie chart will help us to determine various electrical quantities by knowing any one or two of the four quantities. So this is a Ohms triangle. Is straight away it gives the relation between applied voltage and current passing through it and the resistance of that particular conductor. So this Ohms triangle and this pie chart definitely help us to determine various fundamental quantities in the system. So this slide talks about what about the extreme values of R. So extremely R is equal to 0. So minimum value of the resistance may be 0 or the maximum value of the resistance may be infinity. So practically is resistance is 0 is physically feasible or resistance is equal to infinity. What do you mean by resistance is equal to infinity? Resistance is equal to 0. Now resistance is equal to 0 means resistance is nothing but that is the property of any physically existing system. If the resistance is equal to 0 means there is no opposition at all. If there is no opposition, then if you are applying some amount of voltage across that particular element, now without any opposition, so maximum amount of current or current will flow through that particular conductor. Now for that conductor, in that particular conductor, for that current, now if there is no opposition means how much of current we can see through that particular conductor, so the current will be maximum. Because the simple reason behind this is if the resistance is equal to 0, means straight away the current will be maximum in its quantity. So maximum amount of current we can see if the resistance offered by the conductor to that supplied voltage is equal to 0. Then the next extreme condition is R may be equal to infinity. If R is equal to infinity, what do you mean by that? R is equal to infinity is nothing but infinite amount of resistance offered to that supplied voltage. Now, infinite amount of resistance is, because of this infinite amount of resistance, now if you are applying some voltage to that particular conductor, then whatever the current value, current is trying to pass through that conductor is gradually it reduces to 0, because the opposition is nothing but the infinite in magnitude. If the opposition is infinite in the magnitude, then straight away the current try to penetrate through that particular conductor, it becomes 0. But practically these two are extreme conditions, because in the beginning itself I told you very clearly that extreme conditions, because practically if you could see R is equal to 0 and R is equal to infinity means in the majority of the cases these two instants are not possible. Now always any system, if it is existing, means R may not be 0, R is equal to infinity is also not possible. Between R is equal to 0 to infinity, that resistance value may be possible. R is equal to infinity means it is too large. R is equal to 0 means it is very too small. Better don't represent R is equal to 0 and R is equal to infinity. R is equal to infinity means it is too large in the magnitude. R is equal to 0 means it is very too small in the magnitude. If R is equal to 0 means there is no opposition. If there is no opposition means simply the terminals are short circuited by itself. The conductor itself, it will be short circuited. Now R is equal to infinity. R is equal to infinity means the conductor gets open circuited. Now open circuited means whatever the resistance suffered by the conductor, infinity. So open circuit nature is nothing but the resistance offered by the open circuit is equal to infinity. The resistance offered by the short circuit is nothing but it is equal to 0. So the extreme conditions I have again, with the help of one simple example, I would like to highlight why R is equal to 0. If R is equal to 0 means the number of collisions, because R is equal to 0 is nothing but what about the opposition? There is no opposition means if there is no opposition means there is no collisions with other charged particles through the conductor. So no more collisions for electrons within the material. So free flow of current. So there is no drop at all. So if there is no drop, so the current will be maximum in the magnitude. Now instead of R is equal to 0, if any for some finite value, if you are taking R is equal to 1 ohm or 2 ohms or 3 ohms or 4 ohms, something in between two extreme values that is equal to 0 and infinity. Now if you could take that, then there is some opposition by the body itself. Because of this opposition, what happens? So some amount of collisions may take place. For that collisions, you have to spend some amount of energy to overcome the loss. So which is called as a voltage drop. Voltage drop is nothing but you have to sacrifice some amount of electrical energy to overcome the energy loss due to electrons collisions. Or electrons is nothing but the free charge particles collisions. When the free charge particles collide itself or collide with other charge particles, some amount of electrical energy it will be lost. So that in order to overcome that electrical energy, so externally you have to spend or externally you have to supply some external voltage. That voltage is nothing but extra voltage needed to overcome the drop due to electrons or charge particles collisions in the material. So this happens in the system if R is finite in the magnitude, neither 0 nor infinity. Now if R is finite, then there will be collision. So in order to overcome that electrons or free charge particles collisions, you have to supply some amount of extra voltage in order to meet the voltage drop. So what are the potential changes of current in a circuit? Now potential changes of current in a circuit, now it can be explained with the help of a beautiful animated video. Now see, in the first slide, if you are taking, in the first row, if you could see, high energy current, whenever it is passing through a resistance, now some amount of resistance that media will be offered, that media it will be offered some amount of resistance to high energy current, then opposition is there, so automatically high becomes low. So high energy current becomes low energy current. So this happened because there will be a voltage drop. There will be a potential drop. So whenever the resistance is there, definitely there will be a drop in the voltage. Just now also I told you very clearly, for finite amount of resistance, definitely there will be a collision among the free charge particles. Now, because of that collisions among the free charge particles, there will be a drop in the voltage. Now, the same thing here also, it can be see with the help of this PPT, that high energy current, whenever this current is passing through any conductor having finite amount of resistance, now because of this finite amount of resistance, definitely there will be a potential drop or voltage drop. Now once the voltage drop happened in the material or in the conductor, then this high energy current becomes low energy current. Now in the same manner, if the low energy current is entering into a voltage source, second one is voltage source. Now whenever the low energy current is entering into a voltage source, then voltage source is add some energy to the current. So low energy current becomes high energy current. Now potential rise across a power source. Now on the right side of the slide, if you could see, if the current is entering into a battery, if the current is entering into a battery from the negative plate. Now the negative plate is nothing but at that particular plate or at that particular side of the battery, the electrons have very less energy. So whenever the current is entering through that particular terminal of the battery, the current will be increased. So it will gain some high energy. It means electrons will get energy boost. So the battery voltage also increases. So voltage also increased. Then in the same manner, potential drop across the resistor. Now, whenever current is entering into a resistor, there will be a drop. So finally the voltage is nothing but it will be decreased. So the decreasing in the voltage is called as a voltage drop. So that is nothing but energy is lost in the resistor. Now to overcome the energy lost because of free charge particles collisions in the conductor or material. Voltage drop calculation. See here, the sign polarity of that voltage drop is very, very important. Now here battery I am taking. So this is simple battery. This is one terminal and this is another terminal. This is the positive terminal and this is the negative terminal. Whenever the current is entering to like this, if the current is passing and if the current is entering into the battery at the positive terminal and it is leaving the negative terminal, it means some of the electrical energy we are losing. So the polarity or the sign of this battery is nothing but the negative. In the same manner, if the battery is like this, so this is a negative terminal and this is a positive terminal. If the current is entering into the battery like this, so first the current touches the negative terminal, then positive terminal will appear. So it is leaving the positive terminal. So energy transmitting or energy is passing through the battery from negative plate to the positive plate. So some amount of energy it will be added. So the polarity is nothing but the positive polarity. So this is about the batteries. Coming to the resistor. Suppose this is the resistor. Now current is entering into the resistor like this, and here the movement is very, very important. Through which direction you people are moving. So if the resistance of the resistor is R, if current is entering into the resistor, then movement and the current direction is same, then the polarity is nothing but the negative. And if the resistor is like this R, and this is the current I entering into the resistor, and if the movement is in the opposite direction, then consider the drop is nothing but the positive. So drop becomes positive here, the drop becomes negative here. My sincere appeal here is, whenever the resistance comes into picture, then you please strictly follow these polarities, the polarities of the voltage drops. If the current and the movement in a loop are same, then straight away you can take the drop across the resistor as negative. If the movement and the current are in the opposite directions, straight away just take the drop as a positive. Current and the movement of ours in a loop, if both are opposite, then take it as a positive drop. Similarly, the voltages, polarity of the voltage across the battery is positive and negative. When it is positive, whenever you are traveling from minus to the positive plate of the battery, then it will be positive, or the voltage it becomes negative if the current is entering at the positive terminal and the leaving at the negative terminal.
Like, share and subscribe. Hit the bell icon for more updates.